Hey, you. Do you ever wonder how computers detect spam emails? No? How about how they classify malignant tumors? A little? Well, they use certain algorithms that solve these kinds of problems. Here, we will talk about one of the more famous and commonly used algorithm. Logistic regression. Logistic regression is another technique borrowed by machine learning from the field of statistics. Though having regression in its name, logistic regression is mainly used as a classification algorithm used to assign observations to a discrete set of classes. Some of the examples of classification problems are email spam or not spam, or tumors being malignant or not. Logistic regression is named for the function used at the core of the method, the logistic function. The logistic function, also called the sigmoid function, was developed by statisticians to describe properties of population growth in ecology, rising quickly and maxing out at the carrying capacity of the environment. It's an S-shaped curve that can take any real-valued number and map it into a value between 0 and 1, but never exactly at those limits. This is a logistic function where e is the base of the natural logarithms and value is the actual numerical value that you want to transform. Here is a plot of the numbers between -5 and 5 transformed into the range 0 and 1 using the logistic function. Now that we learned about the logistic function, let's see how it is used in logistic regression. Logistic regression uses an equation as the representation, very much like linear regression. Input values, x, are combined linearly using weights or coefficient values, which is referred to as the Greek capital letter beta, to predict an output value, y. A key difference from linear regression is that the output value being modeled is of binary values, 0 or 1, rather than a numeric value. This is an example of a logistic regression equation, where y is the predicted output, b0 is the bias or intercept term and b1 is the coefficient for the single input value, x. The step from linear regression to logistic regression is kind of straightforward. In the linear regression model, we have modeled the relationship between outcome and features with a linear equation. For classification, we prefer probabilities between 0 and 1, so we wrap the right side of the equation into the logistic function. This forces the output to assume only values between 0 and 1. Now, let us apply the things we learned about the logistic regression model. Let us go back to the tumor example. In this graph, we used the logistic regression model to accurately find out if the tumors are malignant or not. The line in the logistic function shifted and squeezed to fit the data. Classification works better with logistic regression and we can use 0.5 as a threshold in both cases. The inclusion of additional points does not really affect the estimated curve. Besides being commonly used for classification, logistic regression can also predict probabilities. Making predictions with a logistic regression model is as simple as plugging in numbers into the logistic regression equation and calculating a result. Here is a more specific example. Let's say we have a model that can predict whether a person is male or female based on their height, which is completely fictitious by the way, but all for the sake of this example. So given the height of 150 centimeters, is the person male or female? Using this equation, we can calculate that b0 is equal to -100 and b1 is equal to 0.6. Now, use this equation and change the values. Compute the equation. After computing, the answer should be, or a probability of near zero that the person is a male. In practice we can use the probabilities directly. Because this is classification and we want a crisp answer, we can snap the probabilities to a binary class value like this, for example. From the things we learned in this video, we can understand how powerful logistic regression is. But logistic regression cannot do everything. It has some weaknesses. Articles state that logistic regression has been widely used by many different people, but it struggles with its restrictive expressiveness and other models may have better predictive performance. Another disadvantage of the logistic regression model is that the interpretation is more difficult because the interpretation of the weights is multiplicative and not additive. On the good side, the logistic regression model is not only a classification model, but also gives you probabilities. This is a big advantage over models that can only provide the final classification. Knowing that an instance has a 99% probability for a class compared to 51% makes a big difference. That's it. Thanks for watching.